Hola, amigos. Oh God. Diez. No, is German. Es diez en la mañana in Redmond, Washington. Y es tiempo para .NET API review. Uh, Welcome to the last session of the year, I think. And we have more than enough stuff to fill it, and a couple things in a not exactly this order that were sent out in the agenda earlier. So let's get started. Uh, that is not the first thing on the agenda. That
I
goes
think it's
down
the
here. This is the first
yeah.
thing on the agenda. JSON serializer overloads accepting non-generic JSON type info 77051. Aidek, Kalimera.
Right, Kalispera. Um, so,
Got the right word this time.
well, I mean, it depends on your time zone, obviously. Um,
It's always right
so
somewhere.
it was right in your time zone, and mine was right in my time zone. um, Alrighty then. So this proposal basically concerns adding a few serialization and deserialization overloads that we hadn't included in .NET 6 and .NET 7. This proposal specifically came up during a conversation about native AOT support in ASP.NET Core. Now, the issue with most of the serialize and deserialize methods in system text JSON that accept the JSON serializer options default is that they have all been marked as requires unreferenced code and requires dynamic code. And that basically reflects the defaults of these methods. These methods, by default, if you don't pass AJS serializer options, they will use the reflection-based serialization. And as such, they need to be marked as unsafe. But the ASP.NET Core folks have, because they use the JSON serializer options overloads, um, are basically unable to remove a number of linker warnings that this is causing for them. One proposed workaround for that would be to use the serialize and deserialize methods that accept JSON type info of T. These are the overloads that were added in .NET 6 as part of SourceGen. They are not marked as requires unreferenced code, requires dynamic code. But unfortunately, we hadn't so far exposed any untyped overloads that do the same thing. And the ASP.NET Core folks obviously need the untyped ones because they don't necessarily have any static information in terms of the type that they're serializing when they need to serialize it. So that's more or less the motivation for this. The proposal basically includes adding one overload for every single serialize and deserialize method, accepting an untyped JSON type info instance. Now, just as a reminder, JSON type info is the metadata token that system text JSON uses internally. If you have that on hand, it basically means that any sort of whether you populated that using reflection or whether you populated that using SourceGen or whether you populated it using kind of your own logic or your own source generator is kind of irrelevant. You have the token. Therefore, it will drive the serialization or deserialization using whatever metadata exists in that instance. And as such, it doesn't require any annotations as far as linker safety is concerned. Any questions?
Since all of these are in terms of object, is it still providing value to the linker? Like, I don't know how much going through object messes things up with the linker.
It shouldn't mess anything. Like, the reason why linking isn't a concern here is that it accepts any metadata needed to handle that object parametrically. And as such, it is a concern that is extraneous to the scope of the method itself. You might be able to do unsafe stuff when constructing that JSON type info instance, but that's not the purview of the method itself.
So basically, you're saying that the JSON type info statically references everything that it would deserialize. So
Yeah.
in that sense, it's statically, I guess,
Yeah,
visible to the linker.
The JSON type info is the blueprint of this is how you serialize this value, right?
Right.
And as such, the method itself is agnostic with respect to that where that blueprint came from.
Right.
So
I mean,
it basically lets the ASP.NET Core team kind of build their core serialization components using methods that are agnostic with respect to where that metadata came from. So it would work both for reflection, and it would work both for source gen and by extension native AOT.
Right. I mean, I don't have any concerns with the particular proposal. The only observation I would make is that we have, I think, 32 overloads of deserialized already. So there is I mean, I know why we missed it because it's hard to like keep track of all the patterns that we have in this one method alone. But I guess at this point the ship has sailed. We already have 30. So I don't know what to do with that.
Can these methods fail in a way that the generic methods that take a type info cannot, or is it basically the same failure modes?
There is one added failure mode. Obviously, you would get an invalid cast exception if you are passing metadata for a string and the object value you're serializing is an integer.
Sure.
And before, so yeah, the normal overloads JSON type info is generic, so it's trying to remember. Yeah, okay, yeah, so it has to match.
And for what it's worth, we already have untyped variants for the JSON serializer options and JSON serializer context overloads as well. So this isn't really introducing new terrain. It's just adding untyped variants for JSON type info specifically.
Yeah. Well, I know we're the ones asking for it, so no pushback.
So we do not have an overload that takes you the only span of char. Is that intentional?
Probably not. I did construct this list looking at the reference source, but maybe I missed one overload.
Yeah, I was just looking at all the deserialized ones that take a JSON type info of T, and then just saw which ones you have. There's also some ones that you added that the other one doesn't have, like there's no JSON document as far as I can tell. Or JSON element for that matter, that takes the JSON type info.
There are the top two deserialize of T values.
Well, they don't. What I mean is that there's no JSON type info of T overload that takes the JSON. No, there is in the middle. Why does I not see it?
It's the. I don't know.
This happened.
I'm using your catalog. So.
Yeah, I see it on the website. Yeah, never mind. I'm bad at deleting text apparently.
Alright, so I added the missing char one. Here is there. I assume there's nothing else.
8 lines. Yeah, that's right. So yeah, he has 8, including the deserialized async one. And the.
Do we need the string overload then, since string has an implicit conversation to read only span of characters?
Sorry, what was that? You cut off in the beginning.
Sorry, do we need the overload that accepts a string? Because string has an implicit cast operator to read only span of characters. So we can always pass it as span characters.
That is actually a good point. I need to write this down. I was remembering this from last time. So this is something that we talked about, that we should make a decision what to do with these kind of guidelines, because the original guideline that we had was for mainline APIs, we should not force people to go through span because of unclarity about what that means for the compilers, like what the compilers allow and what they do not allow. that included relying on the implicit conversion from string to read-only span of char. But given on how many places we now have added these overloads, there was a concern that we should probably stop doing that and just convince ourselves that the mainline compilers will work fine with it. And people just have to be aware that a string can implicitly convert it to a read-only span of char.
I'm guessing we've also added the string overloads for languages without implicit conversion support.
Yeah, so that was one of the reasons why we had the guidelines originally. But my understanding was that F# since then has implicit compiler knowledge about these particular types. So it doesn't generally accept implicit conversions, but it does do it for certain types, and that's apparently one of those types where they do it for. So it might just work. So basically, the work that I think I have to do is basically just validate that it works in VB and F# the way it works in C#. And then we can have the conversation about whether we are okay with just telling people, like, look, if you see an API taking a read-only span of char, you have to know that you can pass in a string, right? And then maybe that's okay. The one thing that we don't want to do is we don't want people to force to deal with spans directly, because that doesn't work in VB, and that also has the additional complexities of the type system if you can't stash it away and all the other gloriousness that comes with spans. But when you just pass an argument, like, it's fine. I think that's basically the work we have to do. But I think in this particular case, they would probably still add the overload just because the other ones already have them anyway, so we don't really save anything.
Yes, and there is a distinction. The string one rejects null, and the span one, the implicit conversion from string to span accepts null, even though it shouldn't have.
And what do you get? Basically, you get back an empty span, basically?
Null and empty turn into the same thing. Yeah.
Yeah.
Well, technically they're different, but when you feel that you need to care, then Jan is upset at you.
And it's presumably deserializing an empty span basically returns you null? Or it throws?
I think that throws, because only the letters NULL would return null.
Well, in that case, they would both reject null, right? Just
Well,
by a different
one's
path.
argument and the other one's content.
Yeah, so you basically just get a slightly different exception.
The one method I don't see here that I don't know if we need or not is deserialize async enumerable.
Oh, that's a good one.
I need to think about that because deserialize async enumerable is special.
But you have one that takes the T value, right? So why would you not be able to at least basically have the logical equivalent of that?
Yeah, you could have a deserialize async enumerable that returns an async enumerable object question mark. Yeah, I think it's feasible.
Remind me, is async enumerable covariant?
Maybe.
It is, yeah, it is.
Yeah.
Because that's kind of what you want, right? Because you want the return to be still castable to, deserialize. Sorry, async enumerable of customer, for example, right?
Yeah.
Yeah, I mean, could be doable.
I don't see any reason why it couldn't work.
It might just be a ton of duplicated code, but
I think the only difference between this one and the others is that it might need a bit of added implementation behind the scenes, but I don't see any real reason why it couldn't work.
That makes sense. I mean, I have to say, it's a lot of pieces on that pipe now, but I think we crossed that bridge already.
Yep.
I just never realized how many overloads we added to this guy.
Did I get that guy right?
Yeah.
Looks like it.
Cool.
What does serialize
Awesome.
to document do? It just gives you back a document. Why is it not the same as just serialize?
I believe it would its signature would conflict with the serialize to string methods. So therefore, they need to use a different method group.
Oh, because we use serialize to mean give me back the string.
Yep.
I see.
One more dumb question I have is deserialize async returns value task and serialize returns async returns task. Like that, we're okay with that when the new ones as well.
I mean, that's what we have already, so I just kept them for consistency. I'm not sure why, but they are different.
Yeah, so they historically they were different because deserialize was producing a value, and if it would likely complete synchronously, then we basically be allocating a task for no good reason. Whereas with the serialize method, it's not returning a value, so if it completes synchronously, it could just hand back a cached task. So that kind of covers the dominant concern around if I'm doing lots of high throughput operations where nothing's yielding, we end up with lots of extraneous allocation. There is the possibility with value task of handling the asynchronous completion case as well. You generally pool objects that you wrap the value task around. So it is possible if we think that there's an allocation concern here, we could make the serialized one return value task instead of task. The question becomes, how valuable would that actually be, and is it worth the possibly negative impact on the programming model? Value tasks are really only ever await them. So if you need to do anything else with it, by making it a value task, you're basically forcing your consumer to jump through hoops.
Do we have a method like value task to task?
Yeah, it's as task.
And is that the hoop you have to jump through, or is there more to it than that?
That is the primary thing you have to jump. You have to know to do it. The concern is you don't know to do it.
Yeah.
We have an analyzer that tries to detect the worst cases of it. And the implementation of value task itself tries to detect if you misuse it. The problem is the only place in value task itself that we can detect misuse is if it's actually wrapped around one of these other implementations. If it's just wrapped around a task, you basically inherit the behavior of tasks. So you could be using these things multiple times concurrently and it'll all work just fine until the API that you're using changes to give you back a value task wrapped around something else. And then best case, things break in a really obvious way. Worst case, you get random corruption and you have no idea.
That's awesome.
Yeah, when we wrote third edition, what we said is you need a much more compelling reason to return non-generic value task than you need to return generic value task.
Right.
That basically return for async, asyncified void. The answer is return task, unless you have a really, really, really strong reason to do otherwise.
Yeah. Now the caveat is, if these are advanced APIs, if we expect the non-generic ones are going to be used only by, say, ASP.NET's infrastructure or whatever, and it's always going to be awaiting it, or if not, we know the developers there and we can talk to them about doing the right things. Like, if we think there's a benefit to making a value task, we can. It's just we just want to do so thoughtfully.
Right.
But it would seem weird to me that the untyped one, or the weakly typed one, would be value task, and the strongly typed one would be reference task.
I mean, my default position, we just match what we already have, and I think that's what's on the screen.
Yeah, that would be my preference. I mean, I would say, because once you have this requirement, I would think you would have it for both cases anyways, and then you would have to cook up with something else.
Yeah, the worst case is when you have two overloads that return different things, and we've only done that in the cases where it's like super impactful, like stream.read async, where we were able to add the one that takes a memory we did change the return type to be value task of int, because there it was super common to be just boxing integers left and right.
Right. Yeah, that makes sense. I mean, I would start with task and then basically see what ASP.NET is saying. If they feel like they need more than that, then maybe we need to give them another named method, probably like serialized to value task. Probably the worst name, and that would be a way to do it, right?
Yeah, the only question I had really was like if we've known if there's any known problems that we wanted to fix now,
way to do
like
it,
if we
right.
wanted to make them both tasks,
Right.
both value tasks.
Yeah,
but
the only
it sounds
question
like
I
no,
had
we don't know. Of
really
any
was
known
like
problems, so.
if we've known if there's any known.
Yeah, we know
And
of
then-
problems with value task, right? We
I
don't-
just meant
yeah.
specifically JSON serializer, our existing APIs. Yeah.
Yeah.
And then one more tiny stupid thing is the serialized to node is JSON node question mark nullable JSON node in the generic one today.
Yeah, that makes sense. And document and element are not nullable?
They're both structs.
Oh, that's right.
Well, JSON document's a class, but JSON elements are
Oh,
struct.
yeah.
But I'm assuming we'd never return null to the JSON document. We'd just return an empty JSON document in that case.
Well, I think if the payload was the letters in ULL, we would return the document who had one element whose value was null.
Right. And if JSON element can represent the literal null, is that?
Yeah.
And why does it not hold for the node?
I've been muted all this time, sorry. JSON node represents JSON null as a null JSON node instance.
Ah.
That's by design. There's no way you can have a non-null JSON node representing JSON nulls.
Gotcha. So that's just a different shape of the types then.
But
Yep.
since JSON element is a struct, it needs a I am null representation.
Immutable array comes to mind. Yeah.
Plus JSON element will know where in the document that word null appeared. Not that most people can get at it, but it knows it. Okay,
Right, so
I think we can
then-
move on to the next one.
Thank you.
thank you. That was good.
Still IRIC, add structural equality and order comparison for common collections, 77209.
Oh boy, oh boy.
Oh,
So
yeah.
this basically consolidates a bunch of community proposals for us to add I equality comparator of T and I comparator of T combinators acting on collection types. I found the need for some of these whenever I've been working with source generators, and more specifically when working with incremental source generators, whenever I wanted to define a notion of equality on top of, say, symbols or ASTs or things like that, of that nature. So essentially, this is kind of proposing adding a bunch of combinators where you are passing in an I-equality comparer for the element type, and this thing spits back an I-equality comparer for INemerable of T, read-only member of T, or I-read-only list of T. Using standard sequence equality for the list-like things, and using the set equality for the set-like things, and as far as comparison is concerned, it would be using lexicographic ordering based on the element comparer.
Is that the set and dictionary or lexicographic? You're caring the order that they come out in? Or that you're sorting them and using... It's dependent.
So
Whose
there's
version
no-
of lexicon are you using there?
If you're asking about adding set and dictionary ordering support, that I'm not including because it's hard to define, I would say. Basically, just starting with things that are easy to define and have no ambiguity in terms of how they would define. But basically, to make that a bit more concrete, it is fast to define comparison in sorted dictionaries, but it is infeasibly expensive to do the same thing with hash tables.
Yeah, I think mine. I missed that there was another grouping when you said lexicographic, so I heard set, dictionary, compare
yeah,
using
sorry.
lexicographic ordering, and was like, wait, what? So
Yeah,
sorry, that's my bad.
I can try defining lexicographic ordering. It's basically lexicographic ordering. Lexicographic ordering is a way in which you could define a total order over a list of things using an order on the individual elements. It's how we define ordering in value tuple. It's how any sort of collection-like type could define a total order that can be used in, things like binary search trees and the like.
Sorry, I was away for a second, but remind me, what don't we have I structurally equatable?
We do.
And this one is not the right thing for this?
I have not considered iStructural equatable, to be honest. This has been primarily just responding to users wanting to define equality comparison for types that don't implement that interface.
Right. I don't know enough about that type. My recollection was that it was added for F# to basically allow them to structurally compare, arbitrary object shapes, which I think includes tuples and other things. So I was just wondering whether by doing that, you basically do a bunch of work that they couldn't leverage because they still rely on iStructurally equatable. Or they may already handle it. That's the other. I don't know what they actually handle there. I remember we looked at that I don't know, 8 years ago or whatever, and I forgot everything about it because it was complicated.
I think they're doing a bunch of reflection-based stuff in the F# core library that basically does full-blown structural comparison, including kind of using reflection to query the members. No, sorry, scratch that. Basically, the standard library is implementing structural equality and comparison for all the common types in F#. I'm not sure if iStructural equatable is being used there.
So chat asks, will these comparers allow for structural equality of sequences of records? That has been a big pain point for me in the past.
Sequences of records. I mean, if you have an equality comparison for a record and records have equality implemented out of the box, it means that it should be in principle, right? You would use equality comparer of p_record.default, and by passing it into this combinator, you would be getting back a equality comparer for a sequence of record types.
I mean, sequence meaning itemerable, I suppose, right?
Yeah, or read-only memory or collections and what have you.
So clarified a sequence in a record, for example, a record of list event.
I guess the question then becomes, what does the record equality comparer do by default when one of its members is a collection type, right?
That's a question of a different order. This is not in any ways interfering with the intentional definition of equality of a type definition, right? This is just a means to get back a equality comparer that can be applied extensionally to a bunch of values. So I don't think.
I was going to say, this in no way changes how the C# language defines how the C# compiler emits record equality.
Right, and I think you can override that. I mean, you can say, I want this member to use this kind of equality comparer for the collection to do structural comparisons, right?
You can override on a record any of the built-in. You can change toString, you can change equals. So once you change it, you're responsible for it.
Yeah, but these building blocks would basically allow them to do that, right? So I guess that would be the answer to the customer. Which presumably they do today. They just have to know how to implement the comparer themselves. Versus here, that you would give them the comparer, and then they just have to stitch it together, basically.
Okay, so all of these are taking a defaulted comparer where they're just going to call a quality comparer default.
Correct. Yeah. Guessing these should have been nullable as well in the proposal.
That would probably be required to make it compile. Yeah.
I missed it if we talked about it, but we really think the compare ones are a good idea. Not the equality compare, but the compare ones. Like,
I mean, if you want to define for example, a sorted dictionary that is keyed on a list of things, then I think that would be useful. I won't say that I found frequent use for it, but I've definitely come across situations where I was like, damn, like I probably need that. And writing one is not a trivial exercise by any stretch of the imagination.
But do we actually have comparable for tuples today? We do, right? Don't they?
We do, yeah. Yeah.
I mean, I've certainly had dictionaries where my key was a compound key, but I don't think I've ever had one where it's literally a collection. But yeah, I mean, I guess if you have it, it's convenient to have. But
yeah, I think Seaboard did the Seaboard implementation did a bunch of tricks like that, and it was like I'm not saying that this could be used in the Seaboard implementation. Obviously, that was doing different things, but it is a problem that comes up from time to time.
And Stephen, your concern is just that you basically have an O(n) squared algorithm when you combine them?
yeah, or also it's, yes, that's one concern. Another is comparing, it's very vague, hand-wavy concern, but comparing lists of things for equality or inequality makes sense to me. But for ordering, it feels like there's a lot of opinion in there about.
I'll say that mathematically speaking, it's very unambiguous how you define ordering in collections of things of variadic length, no less. And you know, as has been mentioned, this is being used in many languages, primarily functional languages, and F# is doing it as well. I don't think you'd find yourself with any problems or any ambiguities if you give it a total order
It's not
for
that
the
not
element type.
ambiguities, but like, it just seems weird to me that we have an opinion that, you know, if I use this with a string, like the string S is somehow ordered after the string A, B, C, D, E, F, G, because S is later than A.
Yeah.
Even though S is shorter than A, B, C, D, E, F, G. So it feels like it's like that example. It's not clear to me which sort order someone would want, and we're basically picking one as part of saying that these are sort of implicitly lexicographic with each element.
I think in most cases you just need a total order, and you do not necessarily care about the order in which things come about. In some cases it might not be, and you want to build something that's a bit more elaborate, that does take the string length into account as a first comparison. But I don't think that consumers of this particular brand of combinators would necessarily care about that.
And to the point of this being like standard in math, isn't that also how strings are sorted? Like if I compare two strings, isn't that the behavior?
Yeah.
S is greater than A, B, C, D, E, F, G. So like
Yep.
shows that it's pretty standard.
It is.
Yeah, I guess my concern is just we're basically saying that this is the comparer. So I don't know.
Like, do you want to put lexicographic in the name, Steve?
Maybe. I don't know. Maybe. Or people can tell me my concerns are stupid.
I mean, we don't do that in value tuple. Like value tuple does do lex ordering, but we don't explicitly call that out.
But you can't compare. What happens if you compare a value tuple of arity 3 to a value tuple of arity 5?
Oh, you can't because you're constrained by the type, but it's basically a projection of lexicographic ordering to a fixed arity.
I mean, so I don't really see the parallel with value tuple because you're basically comparing two things with the same number of elements, and so you're just comparing each of them pairwise.
It's just a special case. So you take the subset of things that are of length n are essentially tuples. But if you say, oh, my n is variable, then you have a bigger space. But the comparison semantics are one and the same.
If no one else has a concern, we can move on.
I mean, like, what convinces me that it's kind of intuitive is that that's the behavior of string already, right? So I think if it matches what string comparison does by default, I think it seems fine once you convert the string to an enumerable of char that you get the same behavior, right? That seems unproblematic. I mean, it's not to say.
What does this do when the lengths are equal, but one is the prefix of the other? Does it then factor in length?
If the length is equal and one is a prefix of the other, then they should be equal, shouldn't they?
No. If one is a pure prefix of the other,
yeah. So
the lengths are not equal.
S is considered lower than S1.
Right. That's my question. So that's what it is. It factors basically when it gets to the end of one sequence, whichever one is longer is considered greater.
I believe so. Yeah.
Yeah.
For strings, at least. I don't know what the comparer does that Eric proposes.
For C strings, that comparison fell out naturally because null is the terminator was 0, which sorted above everything else. But I think logically, it's end of list sorts higher than list continues.
Right.
I'll move on. My next question, I don't know if anyone raised it yet. So the I read-only interfaces. So this basically means that you can only use this when your types implement those interfaces. Most of our collections do. Not all of them do. But the ones that don't, I guess they would end up using the IEnumerable. Is this basically saying that moving forward, we expect mutable collection should be implementing the read-only interfaces? Like, if we basically put that, do we say that in design guidelines?
I don't think we've ever written it down, but that's the guidelines we used ever since we implemented those, added those read-only interfaces because we couldn't have the hierarchy fixed, right?
Yeah, I don't remember anything specifically talking about like I read-only list, but I can take a note for whatever our next update is.
Yeah, I mean, we have done it incrementally. I'm pretty sure there's still some collection types where we don't do it for, but I think in practice, if the built-in collection types that most people use as their base types have it, I think I'm okay with that.
Okay.
There is an alternative design that I've outlined further down. If we don't have any other questions for the shape as presented here, there is an alternative proposal that basically says if we actually had the combinators take the T-type of the collection, then it should be possible for us to basically specialize the compare optimizations. Specialize the compare implementations so that they are being optimized for the specific collection type. So I've sketched out one really simple way of doing this. So essentially, if you have your create enumerable compare accept T-enumerable as a type argument, if we find that this type argument is implementing I read-only list, for example, then we can return a list sequence comparer that avoids instead creating enumerators. And of course, we can do the same thing for arrays and other collection types as we please. It does have a few downsides, obviously, as in more type arguments that you need to explicitly populate. But
You're
generally
basically saying
speaking-
we could do this basically at the time of constructing the comparer rather than if we wanted to at the time of calling equals on the comparer.
Correct. That would eliminate the need for any runtime checks, as it were, for doing runtime type tests for T1, T2, and deciding on the spot whether we need to use iList of T or whether we want to use an array comparison, what have you. If you scroll down a bit more, I have the full proposal using that shape.
We can overload on generic arity, right? So we could do both.
We could, but I think the benefit of just passing the type argument means that we are exposing one less method for create enumerable compare, for example. So if you notice, I've removed the create list compare from the set because now we can specialize based on the T enumerable type argument.
But at what cost? No, I mean, it's just the look.
Well, because
Adding the extra generic argument kind of feels off.
well, the problem with this extra generic argument is it can't be inferred.
No.
So
you'd
that
have
means
to-
you now have to specify
yikes.
both of them. So
Yep.
I think that there'd still be value in doing
Singularity one.
the single arity, which can be inferred from the argument.
Well, but that assumes you're passing an argument.
I
You
mean,
still
you
have
have
to
to-
specify the generic type argument if you didn't pass a compare because it was defaulting to null.
True.
Oh, I see. Well, yeah, if you call it with no arguments, then yes.
Yeah, I mean, so maybe that means the defaults only make sense on the dictionary one, because you could have specifying either key or value no, it wouldn't have been enough in that one.
No.
You need to specify both.
So I guess that's my question. Are you basically saying that the only reason you have the list one today is because you don't have enough data at the time of the construction, and then when you pass it in, you have it, and so you only need the enumerable one?
Correct. But that being said, we might be able to add 2 runtime checks in the comparison methods to detect whether your inputs are arrays or lists. Use a corresponding implementation. But I think that might make things more complicated. I kind of
Like we put on the link enumerable, we have something like try get fast count, right? So if all you wanted was to know the count quickly to say no, they're not equal, then try get fast count on both of them. If they both succeed, then that gives you your answer.
Yeah, I guess that would be my question. Like, what's the difference? Is it just you don't have to go through the enumerable, you can just index, and then the indexing operation is faster?
You can index into an iList. You can avoid virtual calls if you find out that your inputs are arrays. You can do all sorts of things. And obviously, I'm kind of, the generic argument is problematic, but I'm kind of rationalizing this as this is an advanced API, and users that want to define an equality comparer for collections, they might as well do the added typing of, what my collection type is int array, or it's, immutable array event.
Where do we expect this to actually be used? Like, do we have known places that will use this in runtime, for example?
I don't have any use cases for runtime in particular, but
What about ASP.NET?
Any collection that is keyed on collections would probably, I haven't done my research here, but I would expect that any sort of place where we're defining a collection that's keyed on a collection of integers, it would be able to avail of these combinators and probably save us a few bespoke compare implementations.
Yeah, I'm basically asking because I'm trying to understand how impactful saving a few virtual calls will be. Like if we're talking about,
Right.
items that only have, lists that only have 2 or 3 items in them, and not on particular hot paths, then you kind of don't care. I'd rather avoid all the extra generic instantiations and complications of trying to special case this or that type. If we think this is going to show up as hot paths with dictionaries with keys that have 1,000 elements in them, then like that's more interesting. But why are you doing that?
Eric, Eric, had you mentioned before something about using, like replacing the cache that we have for lookups for system text JSON with something like this? Would that be
No,
a scenario you had in mind?
no, I would say that that's probably a different thing that concerns kind of using span lookups for dictionaries that are keyed on byte arrays.
I see. They just said numeric keys, so that's what I was wondering. Okay.
Probably not. I think our source generator would be able to avail of some of these because I believe we are currently defining equality comparisons in the incremental source generator implementation. But obviously that's not the hot path. Like I would say that the benefit of this proposal is not necessarily kind of the performance, but basically saving yourself the hassle of writing your own comparer on collections.
I see. Okay, thank you.
So does that make you lean toward one or the other, Steve? Or both?
I don't know.
I mean, what would happen if we start with the simpler one, which is basically the top proposal, but we basically get rid of the list one? We just say you only have the enumerable one and the memory one. And then if we feel like, okay, there are cases where the generic would be helpful, we can add the other overloads later. Or would that be bad?
I think we'd start seeing requests of adding bespoke implementations for array overloads rather for array, mutable array, and every single thing that implements enumerable of t. I think the nice thing about the generic variant is that you just add one set of APIs and we can go about adding specializations for the collection types that we care about, and more importantly, any sort of checks that are being done is a cost that you're paying once when you're instantiating the instance. You avoid doing that kind of work in every single comparison.
Oh, I think you're right. I think it's not even about the implementation, right? It's just that the return type needs to be inequality comparer of your collection type, right?
Yeah.
Which the other one would always be just enumerable of t, which
Correct.
is not matching. So I guess it wouldn't even work.
Actually, that's a good point. Call your API usage example, that doesn't actually work, does it?
Inequality compare is contravariant on the T, so
But
it should work.
It flows, right?
Well,
That's why there's
you can't implicitly cast an I-equality compare of I enumerable of char to I-equality compare of an I-equality compare of I enumerable of string to an I-equality compare of string array, can you?
No, you would have to explicitly cast.
Right.
But I mean, you could insert the cast, right? But I think the problem is that you may not be able to do the cast, right? Well, can you in all cases?
You probably can cast it. I'm just pointing out, like, it's not, there's a usability issue.
Yeah. Yeah, I would think that's true.
Well, I don't remember like I-equality compares variants. I'd have to try it.
It's invariant.
Right.
Not invariant, but in
Covariant.
Variant.
Right. But
That one.
yeah, I always mix it up too. So, is the sample code right or wrong? It's right, right?
It wouldn't compile.
Oh, really?
You would have to insert at least a cast. Because equality comparer create enumerable comparer gives you an I equality comparer of I enumerable of t, right? And you can't just
Of
assign
T
that to a
enumerable. That's why it's a second generic argument. It's not I.
No,
enumerable
like
of T.
in the sorry, like we talk different things here. Like at the bottom section, the alternative design, yes, he takes 2 arguments, right? But in the API usage, you see that he doesn't pass any arguments to the create enumerable comparer, right? He's just relies on type inference from the comparer.
So I think it
wait,
actually.
am I looking at something else?
I think it actually will compile because iEquality compare is. You said it was contravariant, right?
It is, yeah.
It's in whatever in is.
Yeah,
Yeah, but,
so
but it's an I equality comparer of string, right? So create enumerable now
contravariant.
creates an I equality comparer of I enumerable of string, and you can't assign that to an I equality comparer of string array. You have to cast it to the array.
You sure?
Yes.
And you can't convert an iEquality compare of iNumerable of string to an iEquality compare of string array?
No, that's a downcast, right?
But
Not
it's
not an upcast.
contravariant.
Sure, but that only controls what you can.
Basically says because you're only going to be passing in string arrays, and every string array is also an iEquality is also an iEnumerable of string. Therefore, you're allowed to cast an iEquality compare of iEnumerable of string to an iEquality compare of string array.
This is
It's
like a terrible interview
Yes.
question because you have the contravariant wrapper around the covariant wrapper of final type. It's fun. All right.
So someone
I
should
win
just
the
try
interview.
it.
I tried it.
It doesn't compile.
That's
There you
not
go.
change char to string, Jeremy.
Oh, right.
Compiles.
Yeah, exactly.
Woohoo!
There is an implicit conversion because of the variance.
Aye.
I
Variance
had
is
a
hard.
feeling. Yeah, well, when you combine it too.
Yeah, it is a downcast, but the downcast is implicitly allowed here.
Right, and then when you're looking at bar here, it will just say that you couldn't invoke it with something that was more weakly typed than string array.
Yeah.
The runtime, the destination's not actually going to enforce it, but the
Yes.
pattern will say it wasn't allowed anymore.
So in that sense, I guess usability-wise, it's fine-ish, right? I mean, it just means if you type var on the far left, you may get a type that you didn't expect, but that doesn't really matter because whatever expects the comparer would implicitly convert it again, right? So it seems fine.
Right, because I think if this here was a IEnumerable of string, then the dictionary one will just cause the implicit sideways cast into iEquality compare of something string.
Yep.
I guess string array because that's the key type.
So that means kind of like we are then okay with the simple shape?
I like the simple shape because it makes generic type inference work.
Right. It just means that if you want the more sophisticated one, we can add overloads later, but does that mean that we now have it should still be unambiguous on the call side because you can't get type inference for the generic like once you take 2 arguments. So that means if somebody wants to call the new methods, they would have to pass arguments and then it's unambiguous again. So we could decide to ship the simple design now and then based on feedback we can add the more complicated one later.
Right.
But it sounds like Eric is saying like he doesn't buy that because as soon as we ship the simple one, people will ask for the more complicated one.
I'll say my heart still lies with the generic one. I think the explicitly specifying the generic argument is relatively small price to pay given that you only do it once.
I mean, that is something where I have to admit I don't have an intuition for because I struggle similar to Stephen with like what do the places where I use that look like? And so that kind of I think would control that. I mean, I kind of agree that once you write, I mean, it seems like there's really no simple case here, right? It's not like as simple as you have a collection, you want to have a path and a comparer, right? So whatever simple scenario you cook up will always involve multiple lines of code anyways. So maybe at that point the comparers are fine. But I would say like don't underestimate the complexity, in terms of typing this when you deal with collections, because you have the generics always now in two places. So it's going to be like an I-quality comparer of something, right? So that
Yeah, I was gonna
quickly
say
becomes
that
fairly ugly.
the problem is your T collection is itself likely to be generic. So you now have a specified generic with a generic in the argument, and that's just a lot
Right.
of angle braces.
Yep.
The flip side, and I think I kind of lean with Eric towards the generic one at this point, is total perf aside. Like any perf we get as a bonus. Logically, with a quality comparison, you specify the T that's being compared, and in the top cases, you're not.
Yep.
You're specifying the sub element, and so I think there's something nice about basically saying I'm creating a comparer for arrays or a comparer for lists. We're specifying the T as you would in any other case where the thing being compared is specified as the generic argument. It kind of sucks that you then also have to specify the subtype, but that also makes sense because you really are specifying two different compares. You're specifying sort of an outer comparer and an inner comparer, and you're specifying the generic type argument that corresponds to each. So I don't know. I think that while there's going to be more angle brackets, I think there's a good reason for it. It's explicit. You get back the type of the compare, like the strongly typed compare that logically makes sense given what you're doing. You avoid needing to have differently named overloads to handle things that were enumerable but not lists. And there's also a potential upside when it comes to performance. So I think I kind of lean towards the alternative design.
Yeah, and I would say that you would be able to get the fastest possible equality compare for byte arrays, for example. Like assuming we find a use case for, byte array comparison, we might as well specialize that. We can make these things as fast as we ever care to.
Right.
So you would get rid of the Arity 1 version entirely?
I think I would get rid of the Arity 1 version. So this is an advanced feature. Let's do the minimal thing we think we can do in terms of surface area that satisfies the need. And I think that's just the alternative design. And then maybe even get rid of something there. But I don't remember what it looks like.
Right, because if we remove the constraint and create a numerable comparer, then memory can be folded into the top one.
Would we want to do that?
It would just have to be special cased in the implementation. I mean, if somebody wants to call a quality comparer.create a numerable comparer, I guess maybe without the relationship, it wouldn't be enough to build the body.
Or we bite the bullet and make read-only memory implement IEnumerable.
I think that would make it would have to call, in the non-array backed one, it would have to call get span every element, or every move next, right?
It wouldn't necessarily have to. It could call the pin method under the covers and do all of that.
That would be the first time we would actually care that dispose got called off of,
Yeah, you would absolutely have to call dispose.
We'd have to give it a finalizer.
I think you basically in its get enumerator, you'd construct an enumerator based on what the read-only memory was backing. So if it was backed by an array, it knows that it's backed by an array. It could just return the array's enumerator basically. It would only have to do the span one in the case of was wrapping a memory manager.
That would be an allocation, which I guess is okay.
I mean, that's the.
It can return a struct enumerator that itself has a, well, every now and then it has to
But
allocate
most
a thing.
get enumerator calls are allocations.
Yeah.
I guess if you go through the interface, yeah.
Right. And we if we did pinning, we'd have to put a finalizer on
Don't we
some
already
aspect of that hierarchy, but
I thought we already had like a enumerator over memory of T somewhere. I swear, like there's one as an extension
I
method.
think we have a
somewhere.
long-standing issue for it. I might be misremembering.
because the trivial implementation of it would mean that you'd have to call git span in every call to move next.
Yeah, memory
that
marshal.
That would make Christoph cry.
Yeah, memory marshal has an enumerator over memory of T.
Oh, so we did add one?
We did add one. It's memory marshal dot to enumerable.
Is it a extension method or a?
No, memory marshal doesn't have extension methods.
Fair enough.
And the implementation literally just yield return span of I. So yeah.
I don't remember why we chose to do this rather than making it IEnumerable.
I want to say it's because we don't really want people working with the memory of T all that often. Like what you're really supposed to do is extract the span from it and then use that, because getting the span from the memory over and over in a loop is expensive.
Right, but we just talked about how to write it in a non-terrible way. Like it took us all of like 14 seconds on a live stream to come up with the answer. So
it comes up with the answer that works if you have an array, but I recall that we have very common scenarios, especially in ML.NET, where things are not backed by an array, correct?
right, and so you would get the get enumerator would end up allocating an object with a finalizer so that it could unpin the memory when it was done. If you use it in the for each statement, the for each will call the dispose will call the unpin, and you'll be fine. But we still need to support the case where somebody calls get enumerator manually and doesn't call dispose on it, because it's perhaps in the history of .NET literally never mattered. But in this case, it would. Which is why the finalizer would be important. I mean, don't add finalizers, make a safe handle.
It sounds like there might be appetite for us to remove the read-only memory overload for now.
I mean, at the same time, I just, as I'm looking through issues, there are at least 3 issues I saw that have asked for compares for read-only memory. Now that said, I think some of them are focused more on string-like scenarios, and I'm not sure this is the right shape for that, but
yeah, because I'm just like, it's if we're taking, the set one is an arity 2, you had to specify the set. The dictionary is an arity 3, where you have to specify the dictionary. Enumerable's arity 2, you have to specify the enumerable. This leaves create memory comparer as this sort of special one, and if we had enough, like, the fallback or the implementation in this generic method could do, it can just do the cast to IEnumerable to implement the IEnumerable one after doing the compatibility check. But it would be nice to get it to leave the constraint, because it's commonly sensible, and this just drives, if we bit the bullet and made read-only memory IEnumerable, then this line disappears. So the question is this the right time? Is this the issue that does it? Do we cut this and reevaluate it after doing a discussion in the new year of read-only memory being IEnumerable? I think it's amazing that even with a sore throat, I talk to fill a vacuum. Because in Proposal 2, I don't like this one because it's the odd man out. So I think my opinion, if we're going with the arity 2 for create enumerable, is we cut the create memory comparers, and we can talk about them again in the new year, but we should instead first see if we should just make read-only memory be enumerable.
Sounds good.
Fine with that.
I think one kind of piece of trivia that might be worth bringing up here is that given that we're going for the second approach, iEquality Compare, as you know, has a get hash code implementation. And that basically means that depending on the specialization that's being used, get hash code would be producing different outputs for the same input. So for example, if you are creating an enumerable compare with enumerable of int as a type argument, you would need to build a hash code by iterating over every single element in the sequence. But if you're creating an enumerable compare for int array, we would most likely be using an optimization that would probably be calculating a hash code based on different ways of reading the array. And I believe that this is fine because you only care for get hash code consistency within the context of a single equality compare instance, but I just want to point out that this weirdness will show up.
So the idea is, if I'm understanding what you're saying, Eric, the idea is that you're trying to compute the hash code over the entirety of the memory instance.
Correct, yeah. It means that you might be using different optimizations to calculate the hash code, depending on the value of t-enumerable. You're passing only one equality compare in each dictionary, so that shouldn't cause any consistency issues, but I'm just pointing out that people might say, oh, I'm getting a different int on get hash code, depending on whether t-enumerable is a byte array and whether it's an enumerable byte.
Is this to allow people to shove read-only memory of char into dictionary keys? Is that the scenario here?
That might be one scenario, yes, but there are others as well. It might be just that you're keying on an array of symbols, for example, in a source generator, and you want to detect whether an array of symbols has changed somehow.
Okay. Because I wonder if you do want to shove a read-only memory of char into a dictionary key, for instance, like does it have to compute the hash code not only over every single element, but does it actually have to be identical to string.get hash code? Because will applications fall over dead if it's not? That's why I asked if it was one of the scenarios.
I guess it would be different, but like I said, my assumption is that it shouldn't matter. You only need consistency in the hash codes within the context of a single compare instance. Am I maybe missing a scenario?
I think I've seen cases where people want to put, like, they have a dictionary of like object, and the original key can be like a string or a read-only memory of char or something. So you have to box the read-only memory of char, but at least you're not like substringing every time. At that point, hash code calculation becomes a bit interesting. But that might be overcomplicating things. It sounds like that's not the scenario you're considering here.
No, I wouldn't say so.
Okay.
Eric, in your proposal 2 that's on the screen, you have create enumerable for enumerable, create set for read-only set. I filled in the missing word for you. But then create dictionary, you put dictionary instead of read-only dictionary. Was that intentional?
Sorry, could you repeat that?
your constraint on the T dictionary here is iDictionary instead of iRead-only dictionary. Was that intentional?
I probably not. Probably not. Yeah, generally, while we do expect that T dictionary might be mutable, we want to communicate the fact that people should be using read-only and rather immutable instances when dealing with iQuality Compare. So it should, I think it should be a read-only dictionary. Line 16, small typo after the key compare by need a space. Yep, looks good to me.
All right, anybody have anything else on this one? Done.
Thank you.
Create APIs to deal with processing ASCII text as bytes. 28230.
Yeah. So the good news today, I would like to discuss only a subset of these APIs. A very simple one. If you click on the first link, Jeremy, you will see them. Yeah, so recently we have discussed mainly APIs that were focusing on comparing buffers of ASCII characters. And we haven't gotten to the conclusion yet, and I would like to just get some of the very simple APIs approved so I can make some progress with my PR that has been stale for 2 months. First of all, based on the recent feedback, I have changed the namespace from system buffers text to system text. If anybody disagrees, please let me know. And the second change that was made based on the feedback, I believe, from Tanner, I have changed the ASCII is ASCII method to ASCII is valid.
Yep.
Awesome. And the other methods that I would like to get approved are to upper, to lower, try to upper in place, try to lower in place. These methods allow us to change the case of given ASCII buffer. We can do it either in place or write to a different destination. And since we want to have the possibility to work with both UTF-8 byte buffers and strings, we have for each method we have like 2 options. The source can be either a byte buffer and the destination can be a byte buffer as well, or the source can be a byte and the destination can be a char. And the same goes for char, like the source is char and destination is either char or a byte.
Adam, can you just remind me, we've reviewed this issue several times. I thought the last time we'd approved a bunch of things. Were these not in the set that we'd approved, or am I remembering incorrectly?
So the last time we have focused only on methods that are comparing something, and we were discussing for 2 hours whether they should be throwing or not.
So we didn't get to these yet, basically.
Yes.
Got it. Okay.
Yes. But so basically we had the feedback about the namespace for these methods, about is ASCII being is valid. And there was one more feedback about try to lower about the methods that are performing case conversion in place, whether they should be returning a Boolean as stated here or operation status. That was all of the feedback related to these methods.
What would fail about two upper in place.
Yes. So
Oh, I guess if it hits non-ASCII.
yes, exactly.
So you're instead of throwing, you're
Yeah. So the suggestion was to return operation status, but operation status defines 4 values.
so.
And in case of ASCII, there are only 2 possibilities. It's either a success or it's a failure because it was a non-ASCII. It's impossible that we have run out of space if we are doing in-place conversion for ASCII. And it's also impossible that we are missing some data because if it's Unicode and it's some kind of weird surrogates, it's non-ASCII, and so we are still failing because it's non-ASCII. So just for the sake of usability, I believe it's better, simpler to just remove a boolean so people can just.
So if it's going to out the amount of work that it has already done when it hits a non-ASCII character, that's operation status. If it's going to out 0 and pretend it did no work, even if it did, then that's try. So tries out 0 or null if they return false. We do not have cases that I know of anywhere in the framework that we out or that we return false and out a non-default value.
I see.
The only partial work code we have is operation status, and it doesn't matter that you only return 2 of the 4.
Okay. So based on our feedback, I think it's okay to change it back to operation status, and then I'm going to mention it in the remarks that this method can only return 2 enum values.
Change it to operation status and remove the try, right?
Right. So it'll be 2 upper in place.
Yep.
For the just I'm looking through it. What do we call our out parameters in other cases where we have operation status? Processed isn't a word that I'm used to seeing. Is that?
So we have. I don't know that we've done in places before, because what we always have is consumed and written. But when consumed is guaranteed to be written, as in this case, the question is, should we leave it as 2 or come up with a word to consolidate it to 1? If we've done a operation status where consumed and written are guaranteed to be the same before, then please somebody speak up.
We have base64.encode to UTF in place.
What does that even do?
It returns an operation status and accepts a buffer, a length, and an out int bytes written.
So it uses written and lets you assume that consumed was the same as written.
That's not a valid assumption, is it?
If it doesn't have consumed as a...
Doesn't base64 have a different output length from input length?
Yeah, that's why I was wondering what the function would even be doing.
I think when operation status returns failure, I think it just doesn't tell you how far in it got. Oh, but it can't return failure though, because all input is valid. The only possible air quotes failure it can return is that the buffer was too small. At which point
it could check that before it started. So
yeah, but at that point you still don't know how much.
Well, presumably it did it as a pre-check, and it's either 0 or... Yeah, that one's weird.
In this case, like, elements written kind of makes sense, I think. In place, it's going to be the same, right?
Yeah. Or is the idea that you don't like the word processed?
I would have just expected... I mean, elsewhere we've had, like, bytes read, bytes written, chars read, chars written. So I would have expected this to be out int bytes written or out int byte, chars written or something like that.
Sure. Or converted or something. But yeah.
I'm not a
I would
native
be
speaker,
fine.
so I don't have a strong preference here. Whatever is fine.
Yeah, I think my first concern is on the word elements. That just seems strange.
Elements is our guideline for if it is not bytes or char.
These are bytes or char.
Right, so they should be bytes written and chars written. I'm just like,
Yeah, but initially we had both, like bytes written and chars written. Sorry, bytes read and chars written, for example. But then we got to the conclusion that it's always going to be the same value because it's ASCII. So if you have written 2 characters, you have consumed 2 bytes. That is why we have used the more generic name element, because it refers to both.
Yeah, I mean, at a minimum, I think I would do either bytes. Yeah, I would change elements to bytes or char, and then I don't know what about process to. I guess it's okay, or we could.
well, because
I'd be
once
fine
we're
with
going to
it.
talk about a specific type, then we're picking either the source type or the destination type. So it's either then bytes consumed or bytes written.
Right.
Yeah, I would go with the destination if we did want to settle on something. And instead of processed, you can imagine converted just as a more friendly name. Or written. And then we would just document read and written are always the same here.
Yeah, I think that's what I would do.
Sounds good to
Bytes
me.
written, chars written.
So it's the destination type. So like on the third one, 2 upper will be chars written.
Right.
Because it takes a bytes and then writes a chars.
Right.
I'm clearly not done yet, but yeah.
And then to UTF-16 and from UTF-16, those would similarly change.
Yeah.
So, question on the UTF-16 conversion. For the UTF-8 APIs, we have the ability to replace unknown characters. In UTF-8, it uses a replacement character. For ASCII, when you use system text ASCII, get string or get bytes, things that aren't ASCII are replaced with a literal question mark. Would we want to, as an accelerator here, add an option that says if you see anything that's not ASCII, start substituting question marks?
As opposed to returning failure.
Correct. Can you, if you pull up the existing UTF-8 APIs, basically I'm asking, should that pattern be it?
Yeah, but when I was implementing these methods were frequently used to try to optimistically convert a string, let's say from bytes to a string, assuming that it will be all ASCII. And when we got to the place where it's non-ASCII, we were calling the actual encoding. So performing some more expensive operations. So it was actually an advantage that we were just stopping.
Right, and the UTF-8 APIs, they have an optional parameter that you can pass in that says, do you want me to do the substitution or do you want me to report failure? And it's to mimic the behavior of system text encoding UTF-8.
Okay. So I
couldn't find
usages.
what the existing UTF-8 one is. So
Search to UTF-16 and you should find it. The last match. Replace invalid sequences. That defaults to true for UTF-8. If it sees anything that's not convertible, either way, it gets replaced with the little question mark within the diamond. Or if we wanted to follow the same pattern here, it will be replaced with God knows what, probably just a regular question mark. That's the pretty typical placement option. But that's just for symmetry. If we don't have scenarios where people want to do that, then please disregard it.
I think the only scenario would be consuming this API in ASCII encoding class. Just perform exactly the same thing it's doing right now. Because when I was looking at the ASP.NET repo and .NET Runtime repo, I haven't found any other usage that could benefit from it. However, This wasn't something that I was meant to bring today, but since we are discussing more complex scenarios, I have realized that when ASP.NET is doing the conversion from from UTF-16 to ASCII, they are treating null characters as invalid characters, and then they are stopping the conversion. Right. So I was thinking that maybe we should make this a Boolean flag, like how to treat null characters. And my main motivation for this is that currently ASP.NET maintains its own copy of ASCII utility class, which contains a lot of vectorized code, a lot of bit magic. And I think it would be great if we introduce this API and they could remove their own copy of ASCII utilities.
So I commented in the issue here that I'm going to push back very, very strongly against that. The reason being that null is a perfectly valid ASCII character. Like, what makes null special as opposed to the delete character? A lot of people don't consider the delete character ASCII. Like, should we special case that as well?
I think that in this case, it means it's end of the string. So the string is invalid because somebody has provided,
Right, but you could say the same thing about it containing an embedded end of text character or whatever.
Yes.
Like, null is the most sensitive because of interaction with C-based APIs, but...
This is why I have raised this question on GitHub and haven't included it in the proposal for today.
Yeah,
because I intend to discuss it with Levi tomorrow. I just mentioned it because we started discussing more complex scenarios.
Yeah, I think it's an interesting and valid scenario, but I think it belongs on maybe a different type than this. But yeah, my only opposition would be including it on this type specifically.
Okay.
What did the trim methods trim?
ASCII whitespace. ASCII whitespace.
Is that defined as all of the values that char.is whitespace return true for less than 128?
Yes.
Does it include vertical tab?
Yes. Did we ever come to a conclusion on whether we wanted to allow easy substitution of the of question marks? It's also, if we get requests for it, we could always add overloads later if we don't want to handle it now.
Just to make sure I understand, you could implement that, assuming we didn't support that, to UTF-16 from UTF-16 would return failed. They would output the number of elements processed. You would manually substitute for the character, and then you'd start it again at the new location.
Exactly.
Right? So this would be a convenience if that was a common case to sort of optimize for that.
Right, to avoid you having to write the loop yourself. To be fair, in UTF-8, because UTF-8 is a variable length format, it's a lot harder to write that loop yourself because you need to figure out how many characters to skip. In ASCII, writing that loop yourself would be a lot more trivial because you literally just +1 and move on with your life.
Right.
I don't necessarily like that because, like, what happens if you get a well-formed surrogate pair coming in? Do you put 1 or 2 question marks? How many input elements do you skip? We have apparently already decided that we replace it with 2 question marks, so the whole like just increment 1 character and try again loop should work. Anyway, that's all a way to say you can write the loop yourself if you care.
I mean, I feel like it, with this signature, the default behavior shouldn't be substitution. The default behavior should be returning operation status failed. So we would be talking about an additional overload.
Yes.
Well,
at which point,
if we do it in the future, it's an additional overload. If we do it right now, it's just tacking on an optional parameter.
Right.
Sure. It would be.
And the optional parameter would probably default to true if we had it, just because in almost every case you can think of, people just want you to do the conversion and, yes, fix up bad data, I don't care.
But don't we
say,
then start also having to
I've
consider,
never wanted the substitution to happen.
Yeah.
Yeah, I mean, if you start getting into situations where people do want substitutions, do you also need to get into situations where they have to specify what they want it substituted with?
Yeah, that was one of the things with the UTF-8 APIs, and the reason that we don't allow a replacement character, the reason that we have an opinion about a replacement character there is because we're literally just following the Unicode spec. And the Unicode spec says, thou shalt use this replacement character. This is a little more nebulous because the spec doesn't really have guidance here.
I would be inclined to leave this whole thing off until we have real demand for it.
Sounds good.
It seems like there's some subtlety, there's some complication. We don't really know entirely who we're designing it for. I don't doubt there's a use. Just maybe we at least leave it for when we have concrete use cases to target.
This means we can change ASCII encoding to use this. It just has to write the loop around this itself.
Yes. And that's honestly how UTF-8 encoding works as well, too. It writes the loop itself because the underlying workhorse method doesn't understand replacement characters anyway. It just returns failure up to its caller, and then the caller figures out what to do.
I assume that for ASCII encoding, we're not particularly concerned about performance in the case where there is invalid data.
I wouldn't think so. For UTF-8, we're not.
Okay. Because I assume, I don't know what the implementation of ASCII encoding for this looks like, but is it internally implemented as such a loop, or does it have something more optimized for dealing with replacement?
Currently, it's implemented as a loop. Like we don't vectorize
great.
replacements right now.
Okay, perfect. So
not even the UTF-8 logic vectorizes replacements. Like if you call like encoding.utf8.getString and just give it absolute garbage, like it's going to be slow.
All right, great. Then I think what we have on the screen for this is great.
Yeah. Like it's still O of N. We don't fall over dead if we see it. It's just like we don't optimize it because it's garbage data.
Right. We just fall out of the vectorized loop. We fix it up and then we re-enter.
Yep.
Okay. Great. In the past, Levi, you've expressed... Oh, never mind. I answered my own question. Okay. I was going to say, in the past, you've expressed concerns about when we take bytes, being clear about the encoding of those bytes, and then I realized that we are very clear here. It's in the class state.
Yes. So we're all good.
Yeah.
Since we have some extra time, I'm going to ask an unusual question. Who is going to become an owner of this type if it's in system text? Because initially it was supposed to be part of system buffers.
I mean, last person who touches it, so that's you, Adam. Yes. I don't know, we'll figure it out.
Yeah. You could also imagine, now that we've agreed on these APIs, you could also imagine, Adam, in the future, if people did want the ability to ignore non-ASCII bytes and chars rather than simply failing, now you have a template where you could add overloads and someone could pass in a, like, you know, bad data behavior enum or something. And that could potentially expand the total number of scenarios that we can hit, should people ask for it.
Yeah, and one more thing is that when I was looking for potential usages for these APIs, I have found plenty of them, and none of them were vectorized, and all of the methods that are here are going to be vectorized from day one. Excellent. So I expect to see some nice perf boost.
Yeah. Yeah, the transcoding APIs right now to UTF-16 and from UTF-16 are in fact vectorized right now, but I think that's it.
Yeah, but for example, checking if given set of bytes or characters is valid ASCII, I have seen like at least 10 helper methods doing exactly the same thing. None of them was vectorized.
Yeah, and the funny thing is, like, we actually have that implementation vectorized under the covers. It's just we don't expose it publicly.
Yes.
Whatever.
And recently, Steven has introduced a new memory extension method that allows to implement it also.
Right.
It's called. Oh, damn it! Where is it? Index of any
index of
accept
any
in
accept.
range.
Yeah.
It's a great method. I have actually started using it in ASP.NET when I was searching for users.
Nice. Yeah, we have a very, very tight hand-rolled implementation of the tell me if this buffer is all ASCII or not. If we can change it to use Steve's new method, even better.
My guess is the current. I mean, the new
current
thing
is most
probably
optimal.
not. Yeah.
Yeah, because it's a single operation because we are checking one bit.
Yeah, exactly.
And if we are doing a range comparison, it's more operations.
You mentioned that everything on the screen is vectorized. Does that include trim? I ask only because I'm curious for the scenarios for trim, whether there's typically enough stuff being trimmed off that it warrants the overhead of starting the vectorized loop.
Yeah, historically we've not vectorized trim in the past. I don't think we would now.
Okay, I mean, because it would just be index of any accept, right?
Right, on both ends. Index of any accept and last index of any accept.
Yeah. I mean, if the implementation starts up a vectorized loop, sure. We actually might want to hand roll it as a for loop anyway, as an implementation detail, just because we expect a match will be caught very, very early.
Right. I assume, like, in most our uses of trim, the most common case is nothing is trimmed.
Right.
Or like one character, comma, space, blah, and you trim off the space from the blah.
Yeah, that matches my experience.
Okay, cool.
All right. Anybody have anything else for what's on screen?
I just want to give a shout out to Adam for actually getting this through.
Yeah.
Because it's been a long time coming.
Right. So, a note to Adam and Levi here: this issue number is burned once we hit approve on it. So anything else needs to go into a new issue.
Yeah, but today I have learned a few tricks how to move your issue from October 2022 into the queue to get reviewed sooner.
What you do is you remove the API approved tag and put it back into ready for review blocking.
Yep.
Yeah, but bringing it back where we have a thing in the middle that's approved means that later things won't flow back to it. So this issue number is burned.
Yeah.
Don't move it from approved to bringing it back unless we're changing this.
Yep.
Please.
Unless you are gone and Emo is reviewing. I'm kidding, of course.
He'd feel the same way. He's just not here. I guess we did discuss and. That was an important part of the discussion.
So if we have an operation status based in place API, is it just an accelerator around the APIs above it, or do the APIs above it actually fail if you try passing overlapping buffers?
That's actually a really good question.
Thank you.
Let me check.
Your question is basically, do we even need the in-place ones? I guess
we are currently
the flip...
throwing. We are currently throwing if the span is overlapping.
The alternative is to just make it work if they're overlapping.
If they're perfectly overlapping.
Even if they're not, because we're only ever operating on one byte, so it just changed the direction we iterate.
That gets really complicated, I think.
I was going to say, if it's vectorized, I think that messes things up.
Yeah, you have to, for vectorization, yeah.
we have, at least in like crypto, we have things where we will allow overlap if and only if source is equal to destination. Like no partial overlaps, because we won't guarantee the byte order that we're writing, but we will guarantee that we will read source before writing the destination.
So how about, Adam, does this make sense if we say that the normal to upper and to lower simply forbid overlapping, and the in place actually works with overlapping? Does that make sense?
Is that better than saying that they allow overlapping when it's perfect?
That it seems like a weird, confusing point in the documentation, perhaps, where we say like, okay, it's like source and destination, do they have to be exactly identical? Can one be longer? Like, can destination be longer than source? Is that okay?
Yeah. So if you want, I can relax the requirements, because I'm currently looking at the code and I can see that, yeah, the code is being reused extensively. I haven't touched it in a few months. Maybe I can get back to you tomorrow with the answer.
I think for me it would just be, if we expect two upper in place and two lower in place to be really common, then great. Like, we want that case to be really easy. If we expect it, we want to support it, but it's, we found like one place it'll be used ever. I think I'd rather just make two upper and two lower support it, unless it's going to add expense to every other use case.
I mean, checking for overlaps is, I guess there is a small overhead up front, but it's only, what, a few nanoseconds?
Well, like, if you're checking for overlap to throw on, even on a partial overlap, then you're already doing the overlaps check. The question is, do you then add but if their relative offset is 0, then let it work.
Right.
Which is, cheaper than the exception that's about to be thrown. So the
if
difference.
we have to do the check anyway, then the expense is only being paid for if you're doing the in-place ones.
Yeah. Memory extensions to upper and memory extensions to lower actually forbid passing the same source and destination. Interestingly.
Fair enough. I mean, we could, again, make it work for perfect later if we wanted, but I think this is fine because, to put on what I'm currently thinking of as a Steve Tobe hat, the implementations of these is this one has to check for overlaps and this one doesn't, and then they can both call the same driver method that says, I trust that you've given me sane source and destinations. So this one is a few ifs cheaper. It doesn't have to check is destination length shorter than source's length. It doesn't have to check for partial overlaps. It's like, this one is start working right away.
Yeah, which is great if we think it's going to be like something people actually frequently use. If it's a rare thing and we're just doing it for completeness, then no. Mm-hmm. But it's fine. If Adam, you said you had known places that these would be used, right?
Yes.
Okay.
Let me take a quick look at my list. Yeah, try to lower in place is being used in SystemNet HTTP listener. And to lower is used in QPAC encoder. So they're both being used.
Boom.
Okay. Thank you for the digression.
Okay. We have 10 minutes left. What's theoretically next is adjust or simplify code for numeric int pitter 74518. Which bizarrely doesn't have an owner. Does anybody know what this is and believe it's a 10-minute issue?
I assume Booyah knows what it is.
Yeah, I'm not sure if it's 10 minutes is enough though. But...
Would it make sense to start talking about it?
Yeah, sure. So as we all know, that with numeric int pointer feature, an int is we can release as int pointer, and an uint is an alias for uint pointer, and it also it's giving some built-in functionalities nint and nuint. So now we could do some code simplifications, like using, instead of int pointer 0 or uint pointer 0, just the 0, etc., like as it's shown in the examples. We just want to add analyzer for adjusting the code to simpler form, like instead of just creating a new instance of int pointer or uint pointer using the constructors, just use the numbers. So
Oh yeah, do we have existing analyzers that encourage use of the new language keywords instead of the int pointer and uint pointer types? Or is this the first one?
there is an style rule, ID 09049, which is just like the usage of the int to, int 32 to int. We planning to add to that usage of int pointer into nuint.
Yeah, there's the long-standing style rule that basically says you're using the built-in type name instead of the C# type name. Do you want to simplify to the C# type name?
Yep.
And once int pointer and nint and uint pointer and uint became the same, that rule started firing for that.
Okay.
And we might want to add this change to that one, maybe.
Is there? Oh, sorry. Go ahead, Jeremy.
I was on this top one. There's the notion, like, if it's going to introduce ambiguity, and I feel like if I was passing int pitter.0 or uint pitter.0 as a parameter because I wanted to hit the inint or inuint overload, instead of a casted 0, I would rather see the named 0. Like, for int, you can write 0. For long, you can write 0L. But to me, I would probably rather see inint.zero than the casted 0. Like, maybe I'm the weirdo, but that either says don't change the style if it's going to introduce ambiguity, or...
But like for byte, you'd rather see byte.0 rather than a cast of byte for 0? Because there's no suffix for byte today.
Fair enough. I guess that one I do right. So maybe it's just, maybe it's inertia of believing that these types are special.
Well, to the point that Jeremy made, I see in the like on Discord, for instance, quite a few people still using int pointer as a fully written out type, from the perspective of they like int pointer as an actual pointer type, and they like nint as a native sized integer type. But because they're coming from a C background, those two concepts are very distinct in their minds. And it's just an implementation that .NET happens to use the same backing type for both.
Why did they use int putter rather than void star or int star?
Because there's no need to actually introduce pointers for things that are opaque handles.
I mean, they are pointers.
They are pointers, but it's the same reason. Like if you do Win32 programming, you'll use like hwind a lot rather than using void star, because it's a handle. Like it's not something that you're ever expected to dereference. It's literally an opaque. It's an opaque pointer-sized value.
Sure, but the same goes for void star. Like you don't dereference a void star.
No, but it requires a lot more pain to use it in your code.
Yeah, you have to write
and use
unsafe
reflection. Yeah.
I really doubt the people Levi's referring to on Discord dislike the word unsafe.
Oh no. They embrace it. They just wish you didn't have to write it so often. But yes, it also makes reflection a lot more painful. Anyway, just throwing that out there. That said, if those people would also be absolutely free to turn off these suggestions, right? as long as the suggestions here are maybe granular enough where they could be flipped on and off as needed.
Yeah, because I mean, again, this one that feels opinionated or pointlessly opinionated.
So I have a question. How do you know if you're in a checked context or an unchecked context?
And I think it's not that easy to know that if we need to suggest a checked or unchecked context. So I'm thinking if it applies, we just propose for the two fixer or something, like provide two fixer and let the user choose which one they need.
Well,
Is
so
your question how in the Roslyn APIs you determine what context you're in?
well, what I'm suggesting is there are lots of projects that compile debug checked and compile release unchecked. And how do you make sure that your analyzer works correctly in both cases? Or that your fixer works correctly in both cases? Like, are you going to have to insert a checked block manually?
Because
Yes.
when the analyzer runs, it's run as part of the compiler, so it would know if the current invocation is a checked or unchecked context. It can't
would
do
know
the
only the
dynamic
current
check,
invocation.
but yeah.
And in fact, we like there's a rule working its way through which is going to be like an official recommendation that debug projects get compiled with checked, like whatever people are looking at that. But that said, that means that the behavior might change depending on whether you're compiling debug or release. We've also lost quorum.
Yeah, we've lost everybody.
Yeah. Okay, this was a useful 10 minutes, I think. But I guess what I would like to see then is how do we make sure that these rules are reliable? How do we make sure the fixes are reliable such that depending on how the application is compiled, we don't end up inadvertently changing the behavior?
Yeah, I think we had added the new analyzer in .NET 7 for behavioral changes related to this and numeric and feature, but with that analyzer, it looks like very difficult to say if there is behavioral changes or not. So I'm just planning to suggest offer the two fixer and let the user choose which one better for them. So,
would the user even know which one's correct?
I mean, I guess the user will know more context about the code than the simple static analysis.
Well, sure. I guess it strikes me that like if all we're doing is changing the style of the code, but we want to match the existing behavior, that's really easy for us to do, right? We simply insert a checked block, and that way it's always correct. We didn't change the behavior whatsoever, right?
Yeah, probably that's right.
But it's that said, you have good context as to whether that type of change is viable, whether users might protest if we start inserting checked blocks within their code.
I think you're right. I don't really just make suggestions as shown here. Will be enough.
Two int64 and two uint64, I believe we're actually okay because I don't think those can ever fail.
Can't they?
I don't think they can.
Oh, the 64 versions. Yeah.
Yeah.
Yeah, those are always fair.
Does that sound about right, Boya? Because I'm pretty sure only the conversion to 32-bit can fail, because the backing data type might be 64-bit, so converting to 32-bit is lossy, but converting to 64-bit should always be, it should always be safe.
Well, so yes, there is the semantic question for to int64 of should it throw on a, like, does it understand a negative value? But right now it looks like it's just that it's capable of returning negative values. So yes.
Well, yeah, because nint is signed and newint is unsigned, right? So it's returning the negative value is totally fine.
We don't have the u on. We don't have a signing mismatch. Okay.
Right.
Yeah. So since this is the only time that this could fail is if somebody invents a 128-bit processor, which hasn't happened yet. So
And
right now the substitution is valid.
I want to say we actually have an implicit conversion to long.
I don't know. We have an explicit right here.
Yes, and we have an implicit one. Yep, I found it on APIs. I've done that.
Implicit to or implicit from?
Implicit from nint to long. Because it can never fail.
Because in uint going to ulong is explicit. So it's over here.
Then maybe APIs of .NET is showing me the wrong thing.
Unit pitter. Yeah, on uint pitter, nothing is implicit. Everything's explicit.
So okay. So the second link I just put into chat is in theory the implicit operator for ulong.
Where did this?
Let's blame Emo for this.
Apparently the. Oh no! You found the monotype.
Oh, that's unfortunate.
You looked for in uint, which you should not, because that's not the name of the type. The name of the type is uint pitter.
Okay. We should consider an implicit conversion operator.
We can. I don't know that we can, because we already have an explicit one. I don't know what happens if you have both. I don't want to know what happens if you have both. And you can't rename it because the implicit and explicit's part of the name.
Oh, you're right.
So
see, here I was hoping just to make Boya's life a lot easier. Then she wouldn't have to insert the cast at all. Oh well. Okay. Fair enough.
Yeah. So yeah, I mean, I think that the easy, this one's easy because you already it's returning void star. You already have void star in your context. These are easy. The checked is going to be complicated. The checked is going to be complicated, and then I might be the odd man out for having my initial style change, wanting to use the named 0. So yeah, this one might be fine as proposed. I'm guessing we would want different diagnostic IDs for at least some of these, but I'm not sure.
Oh yeah, what was your plan, to have the same diagnostic ID for everything, or to have different ones?
I think we have different ones.
Okay. Does that kind of make sense then to you, Jeremy?
I didn't hear. Sorry.
Oh, different.
Yeah. Well, some of them feel like they might be able to be consolidated. These two are completely uncontentious, so those might be the same ID.
Yeah.
I mean, they are perfectly a style rule. So again, somebody could want. So maybe each individual block being different is fine, because then that gives more granular control.
So how about this?
It's
then?
really an emo thought.
So, Leia, can we put this back to needs work temporarily? Just get you to maybe write some additional comments on what it looks like for checked versus unchecked, and then you can bring it back to review the next time we have a session. That way more people can take a look at it as well.
Okay. I was gonna not leave any notes on this or change its status at all, because we lost quorum so early.
Yeah.
Yep.
But I think there is actionable feedback though that would help for when we bring it through next time.
Fair enough. Feel encouraged to write it down, because I didn't.
I can write it down.
Thank you.
Just so there's a record of it. And you're okay with that, Boya? I don't want to
Sure.
put unnecessary
Sure,
work
makes
on you.
sense.
Okay, great, awesome. Cool. With that, then, when's the next API review? Is it in the new year?
So I know Kevin poked at Emo asking if the calendar was up to date, asserting that it probably wasn't. Yeah, so the calendar says there are 3 more this year, but I know I'm not going to be here for the rest of the year, and I assume quorum is going to be these. The 20th and 27th seem almost certainly gone. I'm guessing the 13th isn't going to happen, but
Okay.
maybe it will. I did open today saying this is the last one of the year, and no one objected to that statement.
Okay, cool.
So,
So
I expect
we'll do this
it'll be January 3rd, because 2nd's a holiday for us in the U.S., and then 3rd. I guess we're just gonna hit the ground running, or we'll have not attained quorum, because 10 a.m. seems awfully early on the first day back from a really long vacation.
Okay. Sounds good. We'll see you all in the new year then.
Thanks.
So,
And I'll write up comments on that issue.
cool. Thank you, Levi.
Yep.
All right. So, yes, assuming that the stream is still working, because I've had some technical hiccups on my side, that, as we just discussed, concludes almost certainly, maybe there's one next week, I don't know, concludes .NET API review for the year. So, Kagim Sameak, Sunu Jariatan Saeed Alayak, and Froze Noise, every other version of Happy Holidays that I don't have currently memorized or otherwise on my screen. And we will see you in the new year at our typical .NET time on our typical .NET channel. Happy holidays, everybody.
Happy holidays.